All right. So, hi everyone. Welcome back to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, and here, which is India's largest online learning platform for IIT JEE. And on this particular channel, all the concepts of physics, chemistry, and maths are being taught to you completely in English. All right. So today we are starting a new session for a new topic for class 12 students, and this is ray optics. This is lecture number one for ray optics, and today we'll be mostly focusing on reflection of light. All right, before we get started with today's lecture, let me introduce myself for those of you who might not know me yet. So, my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. Now, for almost past 8 years, I've been teaching physics for both the IIT JEE Mains and advanced exams, and all this experience of mine so far had been offline. Now, offline, I have been associated with some of the topmost institutes that you know of for the JEE preparation in India. All right. As a student, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT exams that I took. Now, as a student, I also qualified NTSC Stage 2 and I was in the top 1% of NACP. Now, I have already, with all this offline teaching experience, I've already coached many students to top ranks in the JEE, both mains and advanced. I've helped them crack all their competitive exams and reach their dream colleges by achieving their dream ranks. Now, as I said, in this new era of lockdown period and everything, all of us had to adapt. So I have moved to this online setup, this new setup where I am teaching online. So this is what you guys can do as students also. You also need to adapt. Now you know your traditional ways of learning are no more of any use, right? All the coachings are locked down. So one great way of students to make sure that their studies are going uninterrupted is that by getting the Unacademy subscription. Now, Unacademy is providing an opportunity to keep studying online just as without any interruption, just as you would have studied in any of the offline setups. Now, this subscription will give you advantages like you have regular live classes, you attend regular courses where you have live classes where you get to interact with your educators, so all your learning uh, uh, carries on seamlessly. Now, these classrooms also have live polls and leaderboards, which keep them highly interactive, efficient, and fun. Now, you are also attending a lot of test series. You'll be taking part in test series, and you'll have analysis sessions, which will help you identify your weak areas and pinpoint where you need to focus more. Then you, of course, have live doubt clearing sessions. So again, that's a huge advantage. So for all Unacademy Plus courses, every fourth session has to be a live doubt clearing session. So after every three teaching sessions, the students can go over the theory, can practice their problems, and ask all their doubts related to problem practice or their concepts in that live doubt clearing session. So dedicated session completely for doubts every fourth one, that too. So that'll make sure your doubts never pile up with your Unacademy subscription. Now, on top of all these benefits, Unacademy is also providing you the opportunity to study from India's best educators from the comfort and safety of your home. So till now, all these students had to, if they wanted to study from the topmost educators, had to move to places like Kota, Delhi, which have been traditionally the hub of, coaching institutes for IIT. And now you are getting a chance to study from all the educators from all those areas from the comfort and safety of your home. So as I said, I myself have been associated with some topmost educational institutes in Delhi itself. So now you have a chance to study from me from wherever you are, okay, with this Unacademy subscription. Now, how do you get the subscription? So the first step would be to install the Unacademy app. This installing the Unacademy app will unlock a lot of free features for you. These free features include some free courses that are available on the app. You can just add or attend any of those courses absolutely free without even having to pay any subscription fee. Just by installing the app, you can do that. Then there are a lot of special classes which are free to all students. So you can attend those. And then the quiz, like we just had. So all these features you can unlock without even getting the subscription just by installing the app. And you can unlock all these free features with my code RD Live. So install the app, use this code to unlock all these free features. Okay. Now that will give you a flavor of how your plus courses and how your studies are going to go on when you enroll in plus courses. So if you like the experience, if you find the content interesting, then you can decide to get yourself the plus subscription. And this is how you go about that. First, you'll need to go to the plus section of the app, select your goal as IIT JEE, and click on the get subscription button. Now, after that, you will be redirected to the payment page where you will have a box which will say, do you have a code? So that is where you can put this code, RD Live, that is my code. And if you apply this code, if you click on apply, you will instantly get a 10% off on all your subscription fees. So if we take a look at the subscription fees, so you will realize this is what the subscription fees look like right now. Okay, 12-month subscription comes to about 2,800 a month, and 24-month subscription comes to about 2,100 a month. Trust me, these prices are very reasonable compared to the kind of educators that you are starting from, the kind of quality of education that you'll be getting here. Okay, so compared to that, these prices are nothing. Students pay more than this for their class 5 and 6 tuitions per month. Okay, at these prices, I think this subscription is a must have. Don't forget to use the code RD Live to get your subscriptions. And now you can choose from 2 subscriptions. You can either go for a plus subscription or an iconic subscription. Okay, and also when you click on proceed to pay, you will realize you have a lot of no cost EMI options to make these payments. Okay, so first of all, let me see. So Ethan is here, Amod is here, Rajesh is here, Rajsi is here, and Mahi Ji is here. So hello to all you guys. How you doing? So Ethan says, sir, one request. Rather than alternate days, could you complete it daily so that 12th could wind up soon? Okay, so Ethan, so the issue is that I have to take classes for all students, right? So I have to take classes for 11th also. Now I'm taking a revision series also for class 12 students. So you realize that is an issue. So I'm already taking 5 classes in a week for class 12 students, 2 of your regular syllabus, 3 of your revision for class 11 topics, right? So that is going to be an issue. So Noman says, sir, what is Sorting Hat Technologies? So Sorting Hat Technologies is the registered name of the company. The Unacademy name that you see here is the brand name. Okay. Hi Abhijit Madi, how are you? Okay, so that's what Sorting Hat Technologies is. Yeah, those are the that is the company that owns the brand Unacademy. Okay. All right, sure, sure. All right. So moving forward, let's just quickly tell you about the iconic subscription because most of the students don't know about this. So iconic subscription will take your IIT preparation to the next level. How you will be assigned personal coaches. You will be attending a lot of IIT workshops, receiving expert guidelines from time to time, getting a study planner again, which is very important, and having regular test analysis sessions. So if you are a student who thinks you'll do better under more personalized guidance, then you can go for the iconic subscription. Okay. Next, there is another chance for you to win these subscriptions and test your knowledge and test your standing amongst your peers. So you can take part in the Unacademy Combat. The next Unacademy Combat is going to happen live on the 3rd of January. You can enroll for that using the code RD Live. Do well there. Test your knowledge, test your standing amongst your peers and your competitors. Okay, and also win yourself some really cool prizes and rewards if you do well. Those include year-long subscriptions of Unacademy also. Okay, those of you following us on the JEE English channel of YouTube should also be connecting with us on the Telegram app so that you're receiving timely notifications of all the sessions and lectures happening here. So how many classes it take? Okay, so are you talking about ray optics? So I don't know. It will take a while. It will take a while, at least 3 weeks. At least 3 weeks. Okay. So I'm great, Abhijit. Thank you for asking. Okay. All right. So yes, finally, let's get started with today's discussion. So daily you're telling same thing instead of that upload one recorded short video. You can join other 5 minutes late. Okay, so you realize 5K subscriber daily there are new people joining. So daily it is our responsibility to make sure that everybody gets that information. That information is useful for you guys. See, I have no use for that information. That is completely for you. What kind of subscriptions you can go for, what kind of discounts you can get, what kind of other offerings Unacademy is giving. So that is information purely relevant to you. That is why it's my duty to let all you guys know. Okay, that is not something that is really personally beneficial to me. All right, so don't worry. It's just a matter of 5-10 minutes. Okay. So hello, family home. Good evening to you as well. All right, so let's get started. What is ray optics? So before starting our study of ray optics, let's talk about light a bit. So what do we understand by light? So light or visible electromagnetic radiation within the propagation of electromagnetic spectrum is the range of EM waves that our eyes can detect. Okay, so human eyes can detect a certain range of waves in the electromagnetic spectrum, and that range is called a visible light. Okay. Now, light essentially is a form of energy, and the exact nature and behavior of light is very, very complex, and the theories surrounding it have undergone a lot of changes in the history of physics. So, if you talk about a little bit of history, so earlier people wanted to understand the nature of light, what light exactly is, how it behaves. So Newton had presented a theory called corpuscular theory. So the first theory that we know of traditionally is Newton's corpuscular theory. Okay, so that was a very, very interesting thing. So Newton said that light is made up of corpuscles. Corpuscles mean small particles. Okay, small particles. So he thought that it was a collection of small particles, highly elastic, highly energetic particles. And he explained every phenomena related to light with his theory. He said, okay, these particles are moving, they bounce off, they reflect back just like any mechanical substance would have bounced. So if you take a ball and if you bounce that against a wall, so a very similar thing is exhibited by light, right? In reflection, and then there is refraction. So all those phenomena were explained by Newton using his corpuscular theory. Then at the same time, so Newton suggested light is made up of particles. So that was Newton's idea. Light made of particles, small particles, which he called corpuscles. Okay. Alongside Newton, there was another scientist who gave a theory which was called the wave theory. Numan says, sir, this chapter is controversial. Wave or particle? Oh God, yes. Yes, everything is controversial, but you don't realize the controversy because till now you're focusing mostly on Newtonian mechanics. Okay. So not only this, then you had Huygens theory. Okay. Huygens wave theory was presented. Huygens was another scientist and he said that light is a wave. Now, at that time, when Huygens presented his theory, Newton used to be a big shot in physics. Okay. Is Unacademy going to hire Byju's? Okay, I don't know. I don't know. Where have you heard that? Okay, I think that is highly unlikely. Okay. So as I said, in history, if you look, these two theories were almost given simultaneously. But Newton being Sir Isaac Newton, so Huygens' theory was actually rejected. So Huygens suggested wave nature. He suggested light is wave. So this is what the theory suggested. But because he was competing with Mr. Newton, Sir Isaac Newton, so he did not stand a chance. So back in the history, actually Huygens' theory was rejected. Then there were a lot of experiments. Young, in his famous Young's double slit experiment, actually proved the wave nature of light. Okay, and for almost this theory was almost given in late 1600s or early 1700s. So early 1700s, this theory was accepted. Okay, till almost 1800. For 100 years, people believed this. Then Young performed an experiment where he showed that light, in fact, does exhibit wave nature. So in 1800s, from 1800s to 1900s, wave nature was believed. And then, of course, we will talk about all this as we go down. Then finally came the photoelectric effect, and that changed the entire thing. And then now we know about the dual nature of light. So, as I said, the behavior and exact nature of light has so many complexities that our theories around light have evolved over the years. They have changed back and forth, back and forth. Okay, and finally, we have a set of our understanding about light. We now believe that light has dual nature. It can behave both as particles and as waves. However, we will take that study and we will discuss that in detail later. Right now, let's focus on the study of light. Uh, so essentially, let's talk about optics first. So the study of light and its interaction with matter is termed as optics. So optics is the entire study wherein we are trying to decode and understand the behavior of light. Now the observation and the study of optical phenomena led us to divide the study of optics into two branches. So the entire study, as I said, it's a very complex thing, a very complex phenomena, very complex behavior. So what we do is to study it, we generally divide its study into two branches, and we call these branches ray optics and wave optics. Okay, so optics is the branch where we study the nature of light. We divide that into two categories. Why we do that, I'll just go over and explain. Okay. So first, let me tell you about ray optics. So what exactly is a ray optics? So under the following assumptions, turns out the behavior of light is quite simplified. Okay, so what are the assumptions? First is that light waves propagate through and around objects whose dimensions are much greater than light's wavelength. So if I only consider the light behavior of light under this assumption, so whenever it is moving, it is interacting with matter, wherein the matter should have dimensions which are very very large compared to the wavelength of the light waves. Okay, then turns out its behavior is rather simple. Also, if light does not travel through high gravitational fields, so that is another very interesting thing. Light can interact with gravitational fields also. Again, we do not want to. Okay, hello 51 subs. How are you? Okay, so you are here to prove string theory. So I think you are a little late. 51 subs. String theory you should know has been rejected. Okay, string theory was proposed. It has been rejected. So actually it has been proven to be wrong. Okay, so I don't know how much you're following on that. So I really doubt if you'll be able to prove the string theory. Okay, maybe you can focus on God particles and explain the presence of God particle or something like that, or dark matter. Dark matter is another interesting area of study for physics. Okay, that is where you can contribute still. And of course, the intensity of light rays that are traveling should not be very small. So if I take these three assumptions, if I look at the behavior of light under these three assumptions. So whenever light is passing through or interacting with the matter or passing through holes also, even if it is passing through any holes or spaces, such that those spaces are much larger than the wavelength of the light itself, and the matter with which it is interacting, the size of that matter should be much larger than the light or the wavelength of the light. And if it does not travel in high gravitational fields, so this has another uh, range of applications. There is something called gravitational lensing. Okay, so that is another thing. We won't be talking about that. But if I ignore all these effects, if I ignore these three effects, which will happen when these things are considered, then I understand that the behavior of light gets highly simplified, and that behavior of light can be studied and described using basic geometry. Okay, this study of light is therefore called ray or geometrical optics also, because you can just use basic geometry and explain the behavior of light under these assumptions. So please note, ray optics talks about analysis of behavior of light under a lot of assumptions. Under these assumptions, turns out the behavior is simplified, can be described using simple geometry, and that is what we call a ray optics or geometrical optics. A geometrical optics again is a model of optics that describes light propagation in terms of rays, and hence the name ray optics also. So it is also called geometrical optics. It is also called ray optics because we are explaining all the propagation of light with the help of rays. So what are rays? First, let's talk about all the important terms related to ray optics. So there are terms like luminous object. So what's a luminous object? Any object that emits its own light is called a luminous object. Example: the sun, the stars, a bulb, light bulb, a tube. Okay, anything that is can produce its own light is called a luminous object. Then you have non-luminous objects, so objects that do not emit their own light but become visible due to reflection of light falling on them. They are called non-luminous. Example would be anything that you see around which is not producing its own light, including the moon, the tables, chair, trees, etc. Then you have a ray of light. So what is a ray of light? When I'm studying ray optics, so I'm studying light in terms of rays. I'm trying to visualize light in terms of rays. So a ray is nothing but a straight line which is drawn in the direction of propagation of light. Okay, so that's a ray. So if light is traveling in this direction, then that's a single ray. If light is moving like this, then that's a ray. So any ray is a straight line which is depicting the path of light. Okay. Now then you have a beam of light. A bundle of adjacent light rays is called a beam of light. So if the yellow ones are the rays, then this entire collection is called a beam. So this is what a beam is. So beam contains many rays. Okay, so your beams can be of three types usually. There is a parallel beam of light in which all the light rays are moving parallel. Then there is divergent beam of light in which the rays are diverging from a point. Diverging means spanning out or spreading out. Then you have convergent beam of light where all the rays are converging to a point. Okay, so they are going into a point. They are aiming towards a point, converging there. Okay, so these are the three kinds of beams of light that we will usually encounter. Okay, so now you should be familiar with all the names. So what is a parallel beam? What is a convergent beam? What is a divergent beam? Okay. So any bundle of adjacent light rays, that is a beam. As simple as that. Next, when we will do analysis of geometrical optics, we will also talk about images and objects. So object is something from which the light is getting reflected, which you are seeing. Okay. Now, what is an image? Image is if light coming from any object meets or appears to meet at a point after reflection or refraction. Again, these are two phenomena related to ray optics. We will talk about them later. So, any point after reflection or refraction from where the light appears to come is what we call an image, because that is how your eyes see. So the entire idea is how does the human eye perceive an object? So if you realize how do you see any object? So what happens is imagine if there is an object lying here. Okay, imagine there is an object lying here. So what happens is that light rays from this object reach your eyes. Okay, and let's say you have to notice this point. So imagine light rays are reaching your eyes from this point. So your brain automatically does this. Whenever you have two rays reaching your eyes, so your brain will actually project the rays, will imagine the point of origin from where these would have diverged. So the point of divergence is what you will see. Okay, so the brain automatically makes you see something from the point of divergence of these rays. Now, turns out this point of divergence does not need to be real. Okay, even if you see some rays coming out such that they appear to be diverging from a particular point, your eyes make you see something like there, right? So here is something that you have. This is a real image. So if your eyes were here, imagine if your eyes were here, so all these reflected rays would have entered your eyes and they would have appeared to come from here. Okay, so that is where you would have seen something. Okay, that is what image is. Now, similarly, if you realize if these light, if here these light rays are entering your eyes again, if you take any two rays which are reaching your eyes, they appear to be coming from here. So your brain automatically uh, projects or finds the point of divergence of these rays, and it makes you see the object there. Even if an object is there or not doesn't really matter. So whenever you see something which is not actually there, just because you see it from coming out from a point of divergence, that is what you call image. If there is a real object from where the light rays are diverging, then that thing is called object. Okay. Now, objects and images can be real and virtual again. So this is a virtual object. This is a real object. This is a real image, and that is a virtual image. So what is the difference between these? Let's talk about that a bit. So, real image, an image that is created by real meeting light rays. So, if light rays are actually converging to a point and then diverging from there. So, if they truly diverge from a point where there may be something kept or not, doesn't matter whether there is an object here or not. If the light rays converge to a point and then they appear to be diverging from this point, then you will see an object here. That's how your brain works. That's how our eyes work. So this kind of image is called a real image because the light rays are actually diverging from this point. Okay. Now, if, however, you see an image from a diverging rays, which actually are not diverging, but they appear to be diverging from a point, then this kind of image is called a virtual image. Okay. So again, real images are obtained by real meeting light rays. Okay, and real images can be obtained on screens. Okay, so if you place a photographic plate, if you place a normal screen, you will actually see that image appear there. Okay, however, if the light rays only appear to meet, if the light rays only appear to meet but do not really meet, then the image form is called virtual. Such an image can never be obtained on a screen. Okay, so that's the difference between a real image and a real virtual image. Okay, again, now this is something very interesting. This is something that a lot of you do not know about. This is something that I like to teach. This is something extra that I want to tell you, and this is a very interesting thing which you will study in your college probably. But I think this is a very simple thing, and you should know it will help you understand the behavior of light better. So, as far as all the geometrical optics is concerned, all the behavior of light under the realm of geometrical optics can be explained with the help of Fermat's principle. Okay, T is supposed to be silent. That T is supposed to be silent. So, this is read as Fermat's principle. Okay. Now, Fermat's principle states that the path taken by a ray between two given points is the path that can be traversed in the least time. This is called Fermat's principle of least time. Okay. So it just says that behavior of light is such that in reaching from point A to B, it will always take a path in which will enable it to reach from A to B in the least amount of time. Okay. Now, if you understand this principle, then all the phenomena of geometrical optics can be explained and even derived with the help of this principle. So, what all can be derived? So, in geometrical optics, the nature or the interaction of light that you will see will have the following properties. So, first, you will see there is rectilinear propagation of light. That is one thing that you notice in geometrical optics. Again, rectilinear propagation will not hold if those assumptions are not met, the ones we talked about earlier. So, there you would see light bending. I don't know if you know this. In fact, light tends to bend around high gravitational fields also. So, even around black holes, or even around very heavy stars, any light ray coming will actually bend because of the gravitational field. So light does not always travel in straight lines, by the way. Okay. So I told you there is an entire thing called gravitational lensing. That is, converging and focusing light with the help of gravitational fields. So that's a very interesting thing. That is a place where in vacuum light bends just because of gravity. So rectilinear propagation of light is not a fundamental property of light, please remember. So you study about this, that light has this nature of rectilinear propagation, but that is only true under the assumptions of geometrical optics, which I laid before you. Okay, so under the assumptions of geometrical optics, we see that light exhibits rectilinear propagation. Now, this can be explained with the help of Fermat's principle very easily. So imagine if light had to start from a point A and had to reach a point B. And I told you, what does Fermat's principle tell you? Fermat's principle tells you that light will always take a path which will enable it to reach in the least amount of time. So you realize of all the possible paths, what is the path that light should take so that it reaches from A to B the earliest? It is going to be a straight line path. So this principle automatically is telling you why light moves in straight lines. Again, please note that this principle is valid only under the assumptions of geometrical optics. Okay, so we have to be careful. It's not always true. Okay, so rectilinear propagation of light should be easily explained using this principle that there is no way light could have reached earlier by taking any other path. So if light took this kind of path or any other path, obviously that would have meant more time. Okay, so the shortest path which will enable light to reach from A to B in the least amount of time is this. So this and this cannot be the path. The path has to be a straight line, and that is why light moves in straight lines. Okay, in accordance with Fermat's principle. Then turns out you can even derive the laws of reflection and laws of refraction with the help of Fermat's principle. Now you have studied this. You have studied this in your junior classes. I think the first time you study the laws of reflection properly would be maybe in eighth and then 10th at least. So angle of reflection is always equal to angle of incidence, right? Why is that? Now we will prove that using Fermat's principle. Okay, I will show you the proof of that. And then there is something called principle of reversibility of light. So what does this tell you? This tells you if light moving from A to B takes a certain path, then while moving from B to A, it will exactly retrace its original path. Again, that can also be very easily explained now with the help of Fermat's principle. So let me tell you, those of you who don't know this, so this says if light takes takes a certain path, takes a certain path in reaching from A to B, in reaching from A to B, then while traveling from B to A, traveling from B to A, it will retrace its path. So again, that should be easy to see. See, suppose light had to somehow reach from A to B, then it should have taken the path of least amount of time. So if it found one path of least amount of time, you will realize while coming back also the path of least amount of time would be this only. Okay. So while coming back from B to A, it will have to retrace its exact path. Okay, so Ethan says ray optics light as ray, wave optics light as particle. No, 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 no. Wave optics says light as wave. Light as wave. Okay. And Einstein obviously said yes, it's both. So yes, that has been the kind of study of light that we have had. There have been a lot of contradictions regarding light, a lot of confusion. Okay, in the history of physics. So this is the principle of reversibility. Now, this is not only limited to straight line propagation. You can even have uh, after reflection. So let's say if from A to B. So if there is a point A and there is another point B, uh, like this, and if a light ray takes a certain path in going from A to B, if while going from A to B it took this path, then while coming back after reflection only from B to A, it would have retraced its path. Okay, that is the principle of reversibility of light. Now that is true for rectilinear propagation, even reflection or a refraction. Hi Akshay Patil, how are you? Okay. So this is another interesting consequence. Again, this can also be easily explained with the help of Paramas principle. As I said, if while going from A to B after reflection, if light figured out that this is the path of shortest duration, then while coming from B to A also, this only has to be the path of shortest time. Okay, so light will always follow the path of shortest time. That is what Fermat's principle says. Okay, so it's sad how there is literally no one left who likes physics the way it is. They just study it for the sake of getting job in MNCs. It's been over 50 years and there hasn't been even one physicist. No, that's not true, Ethan. That's not true. There have been so many. There have been so many. Just that you don't realize it on your level. Hey, how can you forget Mr. Stephen Hawking's? Okay, he gave so many theories about black holes, Hawking's radiations, and so many other things. So there are still physicists. Don't worry. There's still a lot of research going on. But the problem is, over a period of time, you realize so much research has already happened that the scope of research gets reduced. There are still a lot of researches happening in the field of quantum physics. So don't worry about it, Ethan. Oh, from India. Hmm. Yeah, that might be the case. That might be the case. So see, anyhow. So yeah, it does happen at a point of time. So in India, there are not a lot of opportunities also available for research, right? Researchers demand a lot of funds, a lot of experimental setups, expensive experimental setups. So I think that's the reason why India lags behind. Trust me. In U.S. universities, the kind of funding that they have for research, the kind of uh, equipments that they have for experiments and testing, they are amazing, and you have nothing compared to that in India. So unfortunately, that is the case. So I myself was in IIT. Trust me, in IIT you won't find too many very costly setups for performing experiments and doing researches. Okay, so so obviously, and IITs are the institutes that get the highest amount of funding from the government. Okay, so if they don't have enough equipments for doing great research, then obviously that's a limitation. That is a limitation. All right. Now let's talk about reflection of light. Okay, so what is a reflection of light? So now that we have familiarized ourselves with the basic terms, we will talk about this phenomena. So reflection is the phenomena of change in direction of a light ray at an interface between two mediums so that it returns to the medium from which it originated. So here is an example. So light is traveling from one medium and at the interface, it bounces back to the original medium. Then this kind of phenomena is called reflection. Okay. Now, this reflection can be broadly divided into two categories. So we talk about two kinds of reflections, one regular and another diffuse. So what is regular reflection? So when a parallel beam of reflected light is obtained from a parallel beam of incident light, then the reflection is said to be from a said to be regular reflection. Okay. So regular reflection will happen from regular surfaces, okay, smooth surfaces. So this is an example of regular reflection. This is what you have as a regular reflection. You see a parallel beam was incident and the reflected beam is also parallel. Then this kind of reflection is called regular. For that to happen, you will realize that the surface has to be regular or smooth. Now, on the other hand, if this reflection happens over a rough surface, something like this, then you realize that the reflected rays will not form a parallel beam. So incident rays are coming in form of a parallel beam, but reflected rays are scattered. So this kind of reflection is called a diffused reflection. Okay, so this is a regular reflection, and this is what you call diffuse. Now, please note the laws of reflection are followed, whether it be a regular reflection or a diffuse reflection. So here also, you will realize that I equals R will happen for all these individual rays. However, just because of the nature of the surface, the reflected rays will be in the scattered form. Okay. So these are again very very basic terms which most of you know about, but we are still going over them. Okay, so don't feel bored and don't think, okay, why are we studying these obvious things? Okay, just consider this as a quick revision also if you know this. Okay, so again, in a diffused reflection, a non-parallel beam of reflected light is obtained when a parallel beam is incident on any surface. Okay, so this type of reflection is called diffused reflection. Okay, or also known as irregular reflection. So I'm just going over the important terms because these important terms are often mentioned in theory and asked in questions. You should be aware of that. Okay. Next, again, talking about some basic terms related to reflection. You have the angle of incidence, which is the angle between the incident ray and the normal at the point of incidence is called the angle of incidence. Then you have angle of reflection, which is the angle between the reflected ray and the normal at the point of incidence. And then you have angle of deviation. So this a lot of people do not understand well. So understand this right here. Okay. So you have angle of incidence, which most of you have studied in class 10th also, probably 8th also. An angle of reflection is also known. Now, in this year, we will talk a lot about the angle of deviation or the deviation produced. Okay, so what is the angle of deviation? Angle of deviation is the angle between the direction of propagation of the incident ray and the direction of propagation of the reflected ray. So if you can see here, the incident ray would have gone like this, right? So this is the direction of propagation of the incident ray, and the reflected ray, you realize, has gone like this. So this angle is called the angle of deviation. This is what I am calling delta. This is the angle by which the light change its path. Okay. Next. Okay, so now let's finally come to the laws of reflection, which again, you guys, most of you must be knowing, but still, let's go over those one more time. So there are two laws of reflection: the incident ray, the reflected ray, and the normal at the point of incidence. All three lie in the same plane. So that's the first law. Okay, so here you can see the plane containing all these three. Okay, I hope this makes it clear that all these three, normal, the incident ray, and the reflected ray, all will always lie in the same plane. It won't happen that you have the incident ray like this, okay, and the normal like this, and reflected ray coming in some other plane. Okay, so the plane cannot change. Okay, all three have to remain in the same plane. Next, the angle of incidence is always equal to the angle of reflection. Again, this also you guys know, so this is also super easy. Now, today we'll prove this with the help of Paramas Principle, that why it should happen. Why would the angle of incidence be always equal to the angle of reflection? So that is something that is definitely going to be new to you guys. So that's what I keep saying. See, don't worry if some things are very easy also in the lecture and some things you think are very basic. Okay, I already know all these. Trust me, in every lecture, I will present you something new and exciting also. Okay, so some things obviously you have to go over again and again, even if they are basic and even if you know them. Now, this is another interesting thing which you would not have studied before the class 12. Now we can write the law of reflection in the vector form. In the vector form, if E I cap is the unit vector along the incident ray, if N cap is the unit vector along the normal, and E R cap is the unit vector along the reflected ray, then these three unit vectors can be related like this. So this is very, very important. Now please remember this formula. In IIT JEE Advanced, especially, they have asked a lot of questions based on this. Okay, they have told you this is the equation of the incident ray, this is the equation of the normal, find the equation of the reflected ray. So this is important. You must remember this. Okay, so let's write this, and this is something new also. So essentially, the idea behind writing the vector form is, if you notice this, so if I am representing the incident ray with the help of a vector, so you realize I can divide this vector into two components, right? One component which is like this, one component which is like this. These will be the two vector components. Now, same thing for the reflected ray. Again, I can break this into two components and into this component. So what you notice is that this component of the ray remains unchanged and this component gets reversed. So the idea is if I can find the dot product between the normal and the incident ray, so that will give me this portion, right? This portion, and this portion gets reversed. So what I'm saying is if I find the dot product and then subtract it two times with the unit vector of the incident ray, then I will get the unit vector along the reflected ray. That is how you get this. Okay, so you can notice that the unit vector along the reflected ray is nothing but the unit vector along the incident ray minus two times the dot product of that, which is giving the component that got reversed. So why two times subtraction? First, you want to make that zero, and then you want to make that component in the opposite direction. So that is why you're getting this form. So memorize this, remember this. This is something new. This is something that you don't study before your class 12. And this is something on which JEE Advanced has asked a lot of questions. Even JEE Mains asks questions on this from time to time. Okay, remember this. Okay. Now let's try and prove the laws of reflection using Paramas principle. Again, this is going to be something new for you guys. So let's see what we are talking about. So as I said, so let's take up a point A. Okay, let's take up a point A and let's take up a point B here. Okay. So let's say that light has to travel from A to B and has to do so after reflecting once. Okay. So there are so many paths which are possible. Okay, let's draw all the possible paths. So maybe light decides to go like this and then like this to be. Okay, that is one possible path. Now the compulsion is it has to go to B after reflection. Okay, so you do not make this. Okay, this is not a possible path. Okay, we are trying to find the path in which the light should reach from A to B after reflecting once. Okay, so let's imagine if this was y1. Okay, so let's give these heights different names. Let's call this y1. Let's say that point A is at a height y1 above the reflecting surface, and let's say that point B is at a height of y2 from the deflecting surface. And let's draw normals. Draw two normals. So let's draw this. Let's draw this, and let's say the perpendicular distance is x. The total distance is this. Horizontal distance between the 2 points is some x. Now you realize I can choose from different paths. Okay, so I have shown you one path. Maybe let's show you another path. Okay, so maybe another path is this. This could have been a possible path, correct? So the idea is, let's assume that it takes a random path. Okay. So let's forget about all the different paths and let's consider one path. Okay. Let's only consider this path and let's assume that the light hits this at some x1 and let's say that this is some x2. Okay. Now the path length covered here would be L1, here would be L2. Okay. Now I want to find the time that light will take in reaching from A to B. So I know if the total path length is L1 plus L2, so I can say since the total path length equals L1 plus L2, time taken by light, how much will that be? Would be equal to L1 plus L2 over C, being the speed of light. Correct? Now that is a constant. Now what I'll do is I will write L1 from this triangle. I can see L1. How much will L1 be? Also, I can see that L1 would be equal to y1 square plus x1 square root of this. And similarly, L2 would be root of y2 square plus x2 square. Now, please note x1 and x2 can be any two random points. This point can be anywhere. It could have been here, it could have been here. So x1 and x2 are variables that you can change. Okay. So nothing piece says, sir, at this time, by solving any material, we solve previous year questions of 40 years. 40 years. Mains hasn't been around for 40 years. Okay. So mains actually started in 2011, if I'm not wrong, or 12. Okay. From 11 or 12, they made this syllabus of this pattern of mains and advanced. So mains papers you won't find before 2011 or 2012. Before that, they used to have another separate examination called AIEEE. And AIEEE also, I think, started in 2002. So I'm not sure how you will find mains questions for the last 40 years. You can find JEE questions for last, IIT JEE questions for last 40 years also, because JEE, I think, was conducted for the first time in 80s. Okay. So what are you saying again? At this time, by solving any material, can we solve? So I'm not sure. I'm not sure just by solving any material if you can solve all the previous questions. It depends on a lot of things. It depends on your understanding of concepts. It depends on your practice level. So not just solving one material would give you that much of practice. Okay. Moving back to this. So what is my time coming out to be? Time is coming out to be root of y1 square plus x1 square x1 square by c. Now I can also write this as root of y2 square plus x minus x1 whole square. Okay. I hope you understand that. X minus x1 whole square. Right. Now what you will realize is that the only variable is x1. X1 is the only variable. Y2 and y1 are fixed. So the points A and B are fixed. What I can change is I can change the point where this light hits this surface, right? So that is on me. I can make it here. I can make it here. X1 is the only variable that I control. So in order to minimize the time, what do I need to do is for minimum time, I know that dt over dx1, that should be 0. Okay, now let's do that. If I differentiate this, what do you get? You will get 2x1 over, so that is for half root of 1 square plus y1 square. Okay, and then you will have minus 2x1, okay, minus 2 times x minus x1 over 2 times root of y2 square minus x minus x1 whole square equals 0, and there would be C also. C is a constant. Okay, got it? Can you follow this? If I differentiate this, if I want to find the minima for the time, then I can find the derivative and put it equal to 0. Now, what I'll realize is that 2 gets cancelled, 2 gets cancelled, the C gets cancelled. So the expression that I'm getting for minima is, therefore, for minimum time, the idea is that x1 over root of y1 square plus x1 square should be equal to x minus x1 over root of y2 square plus, which is x minus x1 whole square. Okay. Now comes the interesting bit. This is x2. Okay, so I can write therefore x1 over, and this is L1. L1 should be equal to x2 over L2. Got it? Now let's see. This was x1, this was x2, this was L1, and this was L2. So if you find out here, what is x1 over L1? X1 over L1 is sine I, which tells me sine I must be equal to, and x2 over L2 is sine R. So here is your proof of the law of reflection using Paramas Principle. Okay. So the only way to reach from A to B in the least amount of time is take such a path for which the angle of incidence would be equal to the angle of reflection. Okay. So again, I'm sure most of you would not have seen this proof. Okay, so you already learned that the angle of incidence is equal to the angle of reflection. Now today you know why. It can be explained with the help of Paramas principle of least time. It can be mathematically proven with the help of Paramas principle of least time. Okay, so that is for that is all the time that I have for today. That is where I would like to wrap up today's session. Next time we will talk about other ideas of reflection, and we will discuss reflection through plane surfaces, reflection through curved surfaces. What are the properties of reflection from there? Okay, and don't worry. I will also prove. I can prove the laws of refraction also using Fermat's principle. Okay, so we are going to have an interesting discussion. So there will be some things that will be not be new to you, but there will be a lot of things that will be new to you as well. All right, so with that, let's wrap up today's session. And before I leave you guys, let me remind you one last time. If you haven't gotten your Unacademy subscriptions, what are you waiting for? I already elaborated all the benefits that this subscription will give you. So, in case you finally wake up and decide to get the subscription, this is how you should be doing it. Go to the plus section of your app, select your goal as IIT JEE, and click on that get subscription button. Then redirect it to the payment page. Use this code RD Live. So, if you like my lectures, if you would like to enroll in my courses, you can dedicate your subscription to me. Okay, if I inspired you to get this subscription, you can use the code RD Live, get yourself a 10% off, and select from any of these subscriptions. Click on proceed to pay and choose a suitable payment plan which suits you. Okay. Next, you can also now choose from the iconic subscription. Iconic subscription, as I told you repeatedly, this will take your JEE preparation to the next level. You will be assigned personal coaches. You will be receiving IIT JEE workshops, receiving expert guidelines, getting study planners, and getting test analysis sessions. Okay. Next, another great chance towards winning those subscriptions is by taking part in the Unacademy Combat, which is the most competitive gamified IIT JEE battle. Okay. Now, the next Unacademy Combat event is going to be hosted live on 3rd of January. You can now enroll using this code RD Live. Do well in those and win yourself some really cool rewards and prizes, including a lot of 1-year subscriptions. All right. Now, if you like today's video, again, as I said, in every video you will find some new things. Also, you will get to learn a lot of new things as well. If you like today's video, then don't forget to press the like button. Okay. Also, do not forget to share it. So as I keep telling you, Unacademy is providing you quality education completely free of cost. Don't forget to share the joy of quality knowledge with all your friends that you know. So this is an attempt by us to reach out to more and more students who cannot afford these subscriptions. We are happy to give away quality education for free, but it is your responsibility to make sure that it reaches more and more people by sharing it. Don't be selfish. Do a good act. Share the video. If you're new to this channel, don't forget to subscribe. to this channel to keep receiving such quality content absolutely free of cost. Now, don't forget to press the bell icon at the end of the lectures so that you are again getting all the notifications of all the lectures that are happening here. The PDF of all the slides used in today's lecture would be available for download very, very soon. And finally, if you are following us on the JEE English channel, it's always a good idea to connect with us on the Telegram app so that you are not missing out on all these sessions and amazing updates you will be getting about all the lectures planned around this channel and other channels of Unacademy also. Okay. Now with that, I'll finally take your leave. So before I leave you guys, let me just remind you one final time. This is my code RD Live. Okay, so if you again like my lectures, if you like to enroll in my courses, if you like me to guide you through your JEE journey, then you can get yourself the Unacademy subscription using this code. Enjoy another 10% off. All right. So we will carry forward this discussion day after tomorrow now. And I hope it was fun for you guys. Okay, so you guys go over the video, revise the concept. If you have any doubts, let that be the first thing that you ask me in the next lecture. All right. So with that, I'll take your leave. You guys take care of yourselves. Bye-bye.